Welcome, everyone. For today's prep, we're going to look at a few more derivative rules. And the first one we're going to look at is product rule. And this is going to tell us how to differentiate a product of two functions. So first, let's look at the rule, and then we'll try a couple examples. All right, so here it is, product rule. And the idea here is we're trying to differentiate a product of two functions. So we have one function, our first function. We have our second function, and we're multiplying those two functions together. And we're trying to differentiate this whole thing. And it's worth mentioning, we have this whole rule, and there's kind of a few ways to kind of write out the rule here. So we can use the ddx notation or more of the shorthand prime notation. So what the rule says is we differentiate just the first function, and then we multiply that by the unchanged version of our second function, plus the first function times the derivative of the second function. So this is the product rule. And kind of at first glance, this probably isn't what you would expect. So it's worth mentioning, note, probably what we would expect is that the derivative of this product, we have one function times another function. If we were kind of using our intuition and kind of thinking back to the sum rule and the difference rule, what we have, how we differentiate addition and subtraction, what you'd expect is that you would just differentiate the first piece. So calculate the derivative of the first piece of the function here. Calculate the derivative of the second piece. And then the multiplication in the middle would just stay in the middle. That's kind of how it worked for addition. So if this was an addition sign, that's precisely, that is true. That would be correct. But because this is multiplication, it unfortunately doesn't work that way. So this is false, not true. So when we have a product of two variable terms, we can't just differentiate the first variable term, differentiate the second variable term, and multiply the results together. We have this more kind of lengthy formula to use. Okay, so again, this is telling us how to differentiate the product of two functions. So you want to think, if you see two variable terms being multiplied together, then you're probably going to have to use product rule or just try to multiply it out. So let's look at an example, example 1. And we have this function y equal to 2x cubed minus 5x times 3x plus 1. So what's going on here is we have this first function, 2x cubed minus 5x. We have the second function, 3x plus 1, and it's not written, but I'm going to put it in there to really emphasize it. We're multiplying those two functions together. So for this one, we could actually do the multiplication here, but let's just see how product rule would work. So we're going to try this one with product rule. Okay. So our derivative, we'll call it y prime. And a way to kind of implement the product rule is to just write down two copies of your function. So we have our 2x cubed minus 5x times 3x plus 1. And then write down a second copy of it. 2x cubed minus 5x times 3x plus 1. And then we put a plus sign in the middle there. And what the product rule does is it says in the first copy, apply the derivative to the first part, the first term, and in the second copy, apply it to the second part. So this is precisely what we're doing in, if we go back up, our formula here. So you differentiate the first term, keep the second term unchanged, and then into it you add the first function unchanged, and then you differentiate the second function. So you can think of that as just writing down two copies, put a plus sign in the middle, and then in the first copy, apply the derivative to the first term, and then in the second copy, apply it to the second function. Okay, so now you just finished differentiating. So let's differentiate this first bracket here. So we look at the first term, derivative of 2x squared. We can do some power rule on that. So I'll bring the 3 down, multiply it with the 2. So we get 6x squared. Derivative of minus 5x is just going to be minus 5. And then we have our 3x plus 1. This is outside the brackets, so that doesn't change. This is also outside the brackets, so it doesn't change. And then finally, we want to differentiate the 3x plus 1. And derivative of 3x is just 3, and derivative of the plus 1 is 0. So over here, we end up with just 3. And there's our derivative. So we're done. So we could have multiplied this out, though. So you could have gone through and distributed the 2x cubed and then distributed the negative 5x. And if you multiplied it out, you would have a polynomial, and then it's just regular power rule. So, but this was just to kind of show how the product rule works. So let's try one more of these. And I want to jump down to example 4. I want to try, something with a trig function here. So here we have the function f of x equal to x squared times cosine x. And now there's no way around it. Here we can't actually simplify this function any further. So we can't multiply that x squared through. But what we have is we have one function of x, one variable term, times another variable term. And we don't normally write the multiplication, but just to emphasize it, we have two variable terms getting multiplied together. So this one we actually do have to use product rule for. So let's try it again. So we'll call our derivative f prime of x. And let's implement the product rule. So we just write down 2 copies of our function. So x squared cosine x squared cosine x. Put a plus sign in the middle. And then for product rule, we apply the derivative in the first copy to the first term. And then in the second copy, we apply the derivative to the second term. And then we just finish differentiating. So derivative of x squared is 2x. So then we also have our cosine x there. That's outside the brackets. Then we have our plus x squared. And then we need to know what's the derivative of cosine. So this is one of our kind of our elementary forms. So one of the ones we should have memorized. In case you don't have it memorized just yet, there is that little circle we can use to kind of help us remember what the derivative of sine and cosine are. So at the top, we can put sine, then cosine, then negative sine, and then negative cosine. And as we go around the circle clockwise, it tells us what all the derivatives are. So we're trying to differentiate cosine. So the derivative of cosine would be negative sine. And just to clean this up just a little bit, I'm going to move the negative and put it in the middle. So we end up with 2x cosine x minus x squared sine x. And that's our derivative. Okay. So that's product rule. Now, related to product rule, we're going to try a few more examples of this in class, but I want to start looking at one more rule here, and that is quotient rule. And quotient rule is kind of related to product rule in some sense. So the way we're kind of implementing the product rule here, we're going to see that carried over into quotient rule. So let's jump ahead, and we're going to look at quotient rule. And as the name suggests, this is the rule we're going to use when we want to differentiate the quotient of two functions, so when we're dividing. And I have the rule written out here. So if we're trying to differentiate a fraction, so we have one function of x divided by another function of x, what do? Well, again, it's probably not what you would first expect. So just like with product rule, it's worth mentioning that the derivative of f of x over a second function does not equal the derivative of the top divided by the derivative of the bottom. Very natural thing to think, but unfortunately it doesn't work like that. So, you know, if this was addition, if we were just adding two functions, well, then it does work like that. But multiplication and division are different. So when we're trying to differentiate a fraction involving x terms on the top and x terms on the bottom, we have this more lengthy formula here. And the numerator is very similar to what we would do with the product rule, except instead of addition, we have minus sign in the middle. So we differentiate the top function, and we multiply that by the bottom function. Then we subtract the top function times the derivative of the bottom function, and then we divide this by the bottom function squared. So we'll kind of see a way to implement this very similar to the product rule, but a little rhyme here to kind of help remember this. Maybe you've heard it if you've taken calc before. The rhyme here is low d high minus high d low. You draw the line. I'm butchering it here. And you square the low. So low d high minus high d low, derivative of the low function. You draw the line and you square the low. All right, so that's, maybe that helps. I don't know. But the interpretation here is when we want to use quotient rule, we do this when we see a fraction and there's variables on both the top and the bottom of the fraction. So generally, if that's the case, then we're going to use quotient rule. So let's just try an example just to see. So here we go. We have a function y equals, and we have a polynomial on the top, and we have a polynomial on the bottom. So this is a rational function. We want to differentiate this thing. And we're going to use quotient rule. So we'll call our derivative y prime. And let's kind of implement it like the product rule. So what we're going to do is we're going to write this fraction as a product. So we'll do top function times the bottom function. And then just like product rule, we do two copies of that. So we'll have a second copy of this product. So top function times the bottom function. And then in the first copy, we apply the derivative to the first function. And in the second copy, we apply the derivative to the second function, just like product rule. But now we put a minus sign in the middle. And then we make this into a big fraction, and we take the denominator and we square it. All right, so that's our quotient rule. And from here, we just want to kind of finish differentiating. And now this derivative is something we can just do. It's a polynomial. So when we differentiate that, we get 2x plus 1. So derivative of x squared is 2x. Derivative of x is just 1. And then the derivative of minus 2 is 0. So we end up with just 2x plus 1. Then we have our x cubed minus 6. That's unchanged. Then we have our minus x squared plus x minus 2. That's unchanged. And then we got to differentiate over here. So the derivative of x cubed is 3x squared. And the derivative of that minus 6 is just 0. So just the derivative here is just 3x squared. And then this is all over x cubed minus 6 squared. So when we do quotient rule, just a couple comments here. You want to be careful. So, and even with product rule. So whenever we differentiate a term like this, make sure you're using parentheses around it, the result. So we really need the parentheses. We need the parentheses here, and the parentheses here. We don't really need the parentheses around the 3x squared. But most of these we actually do need. So if you left off the parentheses, it would be technically incorrect. So that's the first thing. Just be careful with parentheses in your answers. So we need the parentheses. And then the other comment worth mentioning is once we have our denominator, don't multiply that out. Just leave it alone. We don't usually multiply this out. There's cases where we want to square that out, multiply it out, but I can't really think of too many times that we actually do that. So in most cases, it's helpful. Just leave this as the thing squared. Don't try to multiply it out. And also, even though it's tempting, we have an x cubed minus 6 here, and we have an x cubed minus 6 here. Those x cubed minus 6's don't cancel out because we would need a copy of x cubed minus 6 over here. So probably just another thing worth mentioning. Even though it shows up in part of the numerator, that x cubed minus 6 doesn't fully cancel out because it's not over here. All right, so we're going to try a few more of these in class just to get the practice here, but little bit of an introduction to get us started. So we'll see you then. Bye-bye.